Happy Monday, Calculus BC. You miss me? Probably not. Of all classes, I hear less from you guys than I hear from any other section I have. Granted, there's less of you, but proportionally, it's still much less. So hit me up with a message, guys. Um, let's look at a little review, Taylor series, but we're going to add to it, okay? As you know, that a Taylor series is any series where the center is some value, C. And we always set it up by saying that your f of C would have been your first term. And we had a reason for that, because we had a general term. It was always what derivative evaluated at C over what derivative factorial and x minus c raised to whatever derivative we were going to, and we're building it. So obviously your first, if you have a function, it's not a derivative, because when you plug in the 0, it's not a derivative. So it's just its function. So that is why we got just f of c. Whatever f of c is your first term. Then we do the first derivative, and of course at c divided by 1 factorial. This was divided by 0 factorial, and we know that was still 1. Then we have the second derivative evaluated at c, 2 factorial. These are all your constants in front of each term as you build. Now, this has no x minus c, because at x equals to c, you did have x minus c raised to the 0 power. So technically there was 0 power, 1 power, 2 power, okay, and so forth. There's your general term. To find the sum of that series, it would have been the summation of your general form of the constant, x minus c to the n. And we called this a power series, as you recall, in the last lesson. It's called a power series because why? It's a series of terms that have different powers. Okay? If c is 0, that Taylor series is special. It's called Maclaurin. So this is review, because these three that we're going to do here, we're going to do e to the x, sine of x, and cosine of x. These are all the most important power series that you need to learn. Now, to remind you how we do it, we're going to say e to the x is, because we are going to go all the way to the end general term. It's always going to be f of c. Well, in this case, c is 2. Let me write that out, though. F of c times x minus c to the 0 power over 0 factorial, but why waste your time? Plus f prime of c times x minus c over the 1 factorial plus f double prime at c over 2 factorial x minus c squared plus f triple prime of c over 3 factorial x minus c cubed plus f, I'm tired of the tick marks, fourth derivative at c over 4th factorial x minus c to the 4th power plus dot 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 plus. And how do we write it? We write f to the nth derivative at c n factorial x minus c raised to the n. Now our function is e to the x. Let's see, our function is e to the x. I'm sorry, it's not e to the x, it's e to the 5x. That changes things. So what's the derivative? Well, this is e, the first one is e to the 5x, but, all right, e to the 5 times 2 plus the first derivative of e to the 5x is 5 e to the 5x, 5 times 2 x minus 2. Of course, there's a 1 factorial on the bottom. There's a 1 power here, but why bother? Plus the second derivative. So we had e to the 5x. I mean, e is, now that this first derivative is 5e to the 5x. So now it becomes 25e to the 5 times 2 x minus 2 squared over 2, which is 2 factorial. I'm only going to do one more. If I take the third derivative, it's going to be 125 e to the 5x over 3 times 2 is 6, x minus 2 to the third plus plus f to the n of c of 2 raised to n factorial x minus 2 to the nth power. So what did he want me to do? Give the first 4 non-zero. Oh, okay. First 4 non-zero. It was e to the 5x. E to the 5x now is approximately, first 4, it's not exactly now, okay? The terms, e to the 10, and plus 5e to the 10, that's non-zero, plus, I don't know how you're going to handle 25 over 2. I'll just put, I'm going to keep it the way it is, 25 e to the 10, x minus 2 squared over the 2, plus 125 e to the 10 over 6 x minus 2 cubed. So that's my story, and I'm going to stick with it, even though it wasn't e to the x that I was thinking. It's good enough. First 4 non-zero terms, okay. Oh, and the general term, okay. He wanted me to do this. Hope it's general enough to use just the n. E. Let's see, what would that be? N F five to the n, because I had 5 squared, 5 cubed, 5 to the n, and then e to the, well, it's always e to the 10. It was always over n factorial x minus 2 raised to n. Okay, that'll work. There are 3 special Maclaurin series you must know. Oh, that's what I was telling you. That's why I jumped in. I was doing e to the x, sine of x, and cosine of x. Those are pretty much the ones they'll throw at you on AP. For what value of x does e to the x equal the series that you have found? look at problem 2 in the last unit's homework. Well, I'm not going to look back, but if I was to build e to the x again, and we are, I think that was when we were at 0. I don't know. Well, that was here. Right here, we're doing e to the x up here. Lost track. So what was my work? If we were going at x is, or c is 0, because he does say Maclaurin. Okay, he does say Maclaurin. So I need f of 0, f prime of 0. I need f double prime at 0. For doing e to the x, those are pretty easy answers, are they not? Because the derivative, let me not do 0 yet. Let me do x's. E to the x. The derivative is e to the x. The derivative is e to the x. So forth. Now what we do is to get those constants, we say f of 0 would be 1. And then they're all e to the zeros, plugging in the 1. So all my constants will always be, my coefficient will be now, again, f prime at 0 be a 1. F double prime of 0 will be a 1. So I have enough to start building it. Let's build it. E to the x is approximately, or he says equals, because we're going to go to the last. So f of 0 would be a 1 plus another 1, because that's the coefficient with the first derivative, and that would be times, let's see, that's your derivative over 1 factorial times x minus 0, that'd be a 1x, plus another 1. And now remember what happened. It was a 2 power. So it's going to be x to the second, 2 power, over the 2 factorial, plus the third one, which is another 1. X minus 0 is still x. X cubed, 3 factorial. And I remember that term, plus, 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 plus. It was always a 1. X to the n factorial of x. And then when you see the word 4, he's asking me, which x's can I put in? Well, I can use any x's. X's is less than infinity, but greater than negative infinity. Because e to the x is defined everywhere. Now, sine of x. Let me start over here. Sine of x. F of x is sine of x. F prime of x is cosine of x. F double prime of x is negative sine of x. F triple prime of x is negative cosine x. F, the fourth one, starts all over again to sine of x. So then my coefficients would be, again, f of 0, sine of 0, is 0. Coefficient. Cosine of 0 is 1. Negative sine of 0 is 0. Negative cosine of 0, negative 1. Again, starting all over, sine of 0, 0. We could keep continuing. So let's build it. This is a very good review. This is very, very good review for you. 0 times f of 0 was a 0. Plus a 1. And I know I guess I should say, let me back up here. Technically it was still times an x plus the 1 over 1 factorial times an x as well. Okay. That was that one, that was that one. Now I'm at my second derivative. That's minus. Well, it doesn't matter. It's a 0 again. Plus a 0, x squared over 2 factorial. Doesn't really matter. It's supposed to be really minus if you think about it. Now I'm at my third, minus an x third over 3 factorial. Fourth one was back to 0, x to the fourth over 4th factorial. And since I started all over again, the next one's a plus x to the 5 for 5 factorial. Then it was 0 again, x to the 6 over 6 factorial. And then it was a negative x to the 7th over 7 factorial. And that ended in with the general term, which was f to the nth derivative times x over n factorial. Okay, now how do I know if it's plus or minus? So I have to, let me go and go the plus. Oh, that's not good. Need the regular marker. Plus, let me erase that whole thing there. So I need more room. Plus negative 1 to whatever n it is, x to the n. Oh, I need my derivative. F to the n derivative of x x over n factorial. Okay. And again, sine can be less than infinity. X's can be greater than a negative infinity. Let's simplify that though. X minus x cubed over 6 plus x to the 5 over, I think it's 120, minus x to the 7, and I don't know, 7 factorial. May as well repeat that general term again. Well, I didn't even need the f. I didn't even need the f of, it's always going to give me the 1 So I just need to go -1. It's always going to be a -1. There's always going to be an x to the n over n factorial. That was sine. Sine, we remembered it as being alternating, starting with an x, plus minus, plus minus, plus minus, and only using odd powers for the exponent, therefore odd power factorial. Okay, that was 2 of them that we should have. Sent back to you. We're wrapping it up, that's for sure. Bye. I miss you guys. Basically a good thing. Now, we need to know cosine as well. Let me put up my sign here. Sine of x wasn't minus x cubed, because that's a 1, they're odd numbers, over 3 factorial plus x to the 5 over 5 factorial minus x to the 7 over 7 factorial plus x to the 9 over 9 factorial. It kept on going, right? So we can, instead of memorizing another power series, if you memorize sine, you can manipulate your series by adding series together. You can subtract series. You can even do the derivatives of a series. So that gives me, I can take cosine of x then. If I just take the derivative of every single term, the derivative of x is 1. Then I know when I take the derivative of the next term, it's still going to be negative 3x squared over, that was still 3 factorial, which was 6, plus 5x to the 4th over 5 factorial, which is going to cancel out the 5's, but I'm still going to have a 4 times 3 times 2. Then I have a minus 7x to the 6th, 7 factorial. And cosine can also be, x's can be negative infinity to infinity. But by simplifying that answer, I should have done that at the top. I wonder if I can do that. Well, close enough. That's cool. That was real cool. I never did that in front of people. So it turns into 1 minus 3. 3 goes into 6 twice, so it's x squared over 2 plus, this is 5 times 4 times 3 times 1, so the 5's cancel, leaving x to the 4th, leaving you 4 factorial. Because the 5 times 4 times 3 times 2, the 5's canceled, minus 7, no, the 7's going to go away because I'm left with x to the 6th, and the 7 gets canceled, 6 factorial. So I'm not a betting man, but look at the pattern. 1 minus plus minus, the next one has to be plus. Now I'm just guessing right now. X was multiplying x to the 0, x to the 2nd, because 0 is even, if you think about it. X to the 0 is even. 0, 2, 4, 6. I'll bet you any money it's x to the 8 over 8 factorial. And then the general term. I am guessing it's always going to be x. Remember what the derivatives was, so. Looking at my powers, how do I get an odd, even power every time? That would be an x2. And I should have done this at the top too. I think I made a mistake up there. I should have put 2n plus 1. That always gives me no matter what n is, it's always going to be, let's see, I wanted odd, didn't I? Well, just 2n will work. Now, the sign, on the other hand, needed a 2n plus 1 because I want an odd number. And its factorial would have been, well, and the coefficient also would have changed too, because the coefficient of this, well, that never had one. This one does, though. This has a coefficient. This had a 2n. This has a 2n. This one had a 2n. With a 2n minus 1. N minus 1 will always guarantee me an odd number. This is 2n because it's an even number. Anyway, play with that. I'll probably send you another video of this repeated from the I really like the organic chemistry tutor. This is called manipulation techniques. You can subtract series, you can multiply and divide series by a constant all the way across, or you can add and subtract two series. You can add a number to every term of a series. That's what this meant, adding into a series. You can differentiate and integrate a series. To keep it simple, he's doing a Maclaurin series. F of x is sine of x squared. Now, that would be a big job because then, it'd be like this. If f is sine of x squared, then f prime is going to be a 2x, because product rule, or chain rule, you're going to have the derivative of sine of x squared is cosine of x squared. Then you're going to multiply it by the derivative of the inside, which is 2x. Then your second derivative be a pain, because then you got the product rule and the chain rule. So to keep it simple, let's start with our sine of x. Our sine of x, again, as I recall, starts with a 1. And then, no, we'll start with the x. Starts with the x. Then it was a minus x cubed over 3 factorial. Then it was a plus x to the 5 factorial. Then it was a minus x to the 7 factorial, so forth, right? So if all I'm going to do is swap my x, every x, for an x squared, I don't have to do all that work and rebuild it. Sine of x squared will simply be x squared plus x to the 6th over 3 factorial plus x squared to the 5th is x to the 10th over 5 factorial minus x to the 14th, 7 factorial, and we can continue. And he wants the general term, but I just messed up that last one, so I'm going to have to let you think about it. negative 1 to the nth power. I'm sorry, it's going to be negative 1 to the nth power. But they're doubled, so 2n power. Keep it even. X to the 2n plus 1. It's not x anymore, it's x squared. Raised to the 2n plus 1. 2n plus 1 factorial. Whoop, what happened here? There you go. Use the answer in A to find the Maclaurin series for f prime of x. So he wants f prime of x. Well, I guess he's just telling me to take the derivative of every term. So if f of x is x squared, I'm sorry, is sine of x squared, then f prime of x will be equal to. Now he wants me to use my Maclaurin series. So the derivative of x is 1. Derivative of the next term is negative 3 x to the squared over 3 factorial plus 5 x to, wait, I'm doing the wrong problem. I'm doing sine of x. Sine of x squared is here. So the derivative of that would be 2x plus 6x to the 5 over 5 factorial plus 10x to the 9 5 factorial. This was a minus. Minus, that was what going to be, do you see a pattern? 3, 5, you know it's going to be a 7 factorial, and it's going to be an x, 2, 6, add 4, 14, plus, don't forget the coefficient here, and the general term. Looking back up that general term of the first one, that was probably not a 2n plus 1. It was doubled, so it was 4n plus 2. It's a different color. 4n plus 2. So if I just take the derivative of that, that negative 1 is still not going to change. Still a negative 1. I mean, you could say negative 1, then there's a 2n out front, then 2n minus 1 up here. Then that would be a 4n plus 2 in the front, 4n plus 2 in the front of the x, making that a 4n plus 1 over 4n plus 1 factorial. Yeah, I admit you could play around with that general term and try to simplify it more and factor out the 2, stuff like that. I'll look at it closer when I'm not trying to do a video. Find a Maclaurin series for x cosine x, given the first non-zero terms, and he wants the general term. This would be terrible to do all those derivatives with product rules getting bigger and bigger. So why don't we take the x and multiply it by x times our approximation, or not, it wasn't approximation, it was our derivation of cosine that we did up here. It was our derivation of cosine, if you recall. 1 minus x squared over 2. 1 minus x squared over 2 plus, wasn't it x to the 4th, over 4 factorial minus x to the 6th, or 6 factorial, all the way to -1. What was my power did I use? I don't even see it. Didn't I write it up here? Shame on me. Wasn't -1. Did I write it down anywhere? -1 to the first, nth power. Should have wrote it up there. Then it was x to the 2n, I believe. So anyway, -1 to the nth power, x to the 2n divided by 2n factorial. See how that worked. When n was 1, when n was 2, yeah, it has to be 2n factorial, not 2 times n. So boom, boom, boom. So multiply each term by the x. Just distribute each term. X minus x cubed over 2 factorial plus x to the 5 over 4 factorial minus x to the 7th over 6 factorial. The hard part's always that general term. -1 to the n doesn't change, but it was x to the n factorial. You're multiplying it by another x. That gives it an x to the n plus 1 over, and that gives me 2n plus 1 over the 2n plus 1 factorial. Last but not least, use our answer for A, again, which was the cosine, I believe, right? Keep forgetting, yeah, A was the cosine. No, A. A was sine of x squared. Sine of x squared. A was sine of x squared, which was, I don't remember it, x squared plus x to the 6th over 3 factorial plus x to the 10th over 5 factorial plus dot 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 plus general term. I think I left it as -1 to the 2n fact 2n. Look, what did I leave it as? I gotta go back and look at it. It's possible it was just an n. And then the x squared was raised to the 4n plus 2. And then I'm dividing by a 2n plus 1 factorial. I think I'm good with that. But anyway, let me do that. -1 to the n, x to the 4n plus 2 over the 2n plus 1 factorial. Okay, so now if I'm going to integrate this, I am integrating sine of x squared dx. And he said, just give me the, he does want the general. Golly, give the first 4. That means integrate term by term. So that would be equal to, if I integrate the x squared, that'd be x cubed over 3. Integrate the x to the 6th. That would be x to the 7 divided by 7 times the 3 factorial plus x to the 10th becomes x to the 11th over 11 times the 5 factorial. He wants 4 terms plus, it was, I thought it was going to be x to the 14, so it'd be x to the 15 divided by 15 times 7 factorial plus dot 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 -1 to the n. What did I have? I don't remember. I had a -1 to the n. That's not going to change. But x becomes 4n plus a 3 divided by the 4n plus a 3. And I keep the 2n plus 1 factorial. Okay. I'll find a better person teaching this than me. Those general terms can get hard. I will post a small worksheet and my math lab. And I'm going to look to see what haven't we really done in cons. I haven't given you all the credit. Or I did give you the grade in cons, but I haven't looked at it. Since we've been quarantined, I haven't looked at cons to see what needed to be rehashed. Anyway, the homework will look like this. He's reviewing the first 4 non-zero terms of e to the 5x. And then wait a minute, this is the same paper I just did. This is not the homework, this is the same lecture. Okay, I don't have the homework here. Thought I posted it. Let me try to see if it's up there in the cloud. It will be up there though for you, don't worry. Don't fear, I wouldn't let you down. Okay, I don't have it in the cloud right now, but it will be there. So stay tuned. Let me convert this to the video